Well, I'm just doing a few carrier measurements right now. This is connected directly to the back of the transmitter. I did originally put it through two 1 to 20 dividers, making sure that it wasn't too much power. It actually turns out to be not a lot of power at all. For example, this carrier wave right here that we're looking at is, you can see the carrier right there. What is that? Like 10 millivolts squares, so that's 26, probably, what is that, 52 peak to peak, or so anyways. So I'm just doing some measurements. You can see that the sine wave is not a good sine wave. So I think there's a lot of improvements that I can make with this circuit, or at least maybe how I'm, addressing my leads and all that other stuff. And basically, I didn't want to say it, but that's going to necessitate me going back into this thing and, of course, doing the voltage measurements. Like, I'm glad that you mentioned that, to check the voltage measurements, and also about the tube heaters. I noticed that in the original circuit, the one that I was following online, they had their tube heater supply coming from before the transformer, coming directly out of mains. And I wasn't sure why they did that, because I was going to say, well, that doesn't isolate the filament supply. And it, and then when you wrote, it occurred to me that, well, that's probably what they're doing, is they're probably just not, they're not drawing the power from the transformer, so that the transformer has enough power to give the transmitter what it needs. So I'm going to just kind of look at these, I guess the waveforms, do a few more things, and then I'll have to open up the case and start doing some better measurements. I got your email. Thank you for writing. Thank you for looking for that 1S5 tube. And I had a few other points that I'd like to talk to you about that I forgot. So I'll reread your email and get right back with you in a little bit. So I just wanted to show you, I'm looking at the carrier wave now, and this is the top part of the carrier wave kind of zoomed in. I'm thinking that's pretty much the best I want to get right now. Let me see if I can get it just a little bit bigger. Anyways, you can see that there's a ripple on it. I'm gonna see if I can't get the cursors in there to measure the ripple. Well, you can see that, doggone it, is just 60 hertz mains. What do you think? That maybe I need some more filtering capacitors, maybe in the circuit? Problem that I was looking at on the diagram. I don't think I have it. Oh, yeah, here it is. So here's the circuit for the diagram. It's on antiqueradio.org/transmitter.htm. The problem with this that I have is like it's kind of all jumbled together. It's a lot easier for me to read from like left to right, like it is on, say for example, like the All American 5 schematics that you've been getting me from the the rider manual. This is kind of all like in a big, I guess, just square. But anyways, so I was gonna look at this circuit and see kind of like maybe redraw it even and figure out what exactly is going on and how to perhaps improve it, and or figure out where I really need to focus on my lead dress and all that. So I'll work on that and see if I can't get an improvement on this carrier at least. But I also want to basically try to figure out exactly what's going on with the transmitting power. Perhaps, like you were saying, the 6.3 volts is just taking the power down, and then therefore it's just not having enough to transmit. I might even just try that first as see if it's a quick fix. But I do want to learn about how to optimize and generally like create the best circuit I can. So I am learning a lot, but anyways, that's my thoughts right now. I can't say I know what I'm doing. I'm just kind of watching what I've been learning about as far as taking power measurements. Looks like the peak of the output of the transmitter right now is going to be 25 millivolts, 25.6, and basically the top is, I don't know, 24, so we'll just call it 25 millivolts. And then I think I need, for the output, I think for the power, I think I need to get the RMS voltage. V squared over R, I think is going to be the power of the output of this transmitter. So if you do 0.025 and then multiplied to get the RMS voltage, what is that? 0.7071. I'm just looking at this RMS voltage equation. And what is that equal to? All right, so 17 millivolts, 18 millivolts. We can square that. It's less than a millivolt. And then divided by, I guess, the resistance. I'm guessing it's a 50 ohm impedance. I really don't know. I've got it connected to a 50 ohm terminator right here, just in case it is 50 ohms on the internal and whatever this cord might be. I don't know. I'm just going to guess. Of course, I don't know what I'm doing as far as this RF stuff, or as far as anything. That's the truth. But so basically, I'm just going to guess it's 50 ohms divided by 50, and that would be 1 milliwatt. So it's like, what is that? 6 microwatts. That doesn't seem right. So either I'm not doing something right, or my transmitter is grossly underpowered. So think about it some more and I'll get back to you. So I've got the audio output of this signal generator connected directly to basically a mini plug here. So positive is going to the center, and then the ground is going to the outer shield. And at the moment, it looks like the plug is going to be, the signal generator, hold on, it's 500 millivolts a square, so it's probably like, I don't know, we can measure that, but basically you can see that I can turn down the well, no, I'm not running it now. Now I gotta run. So this is nothing. And you can see that if I can turn up the audio level of the signal generator, you can see that the carrier corresponds by modulating the audio, and you can also see that it's pretty badly distorted. But anyways, here's my 300 hertz. At least I'm guessing that's 300 hertz. Let's check it out. And it goes from a peak of one of those blue points to a bottom peak of another blue point. And you can see it's 322 hertz. So basically about 300 hertz. Anyway, so I'm looking at that. I'm just basically looking at the distortion, and I wondered if part of it is because my sine wave is not very perfect. See how it kind of mimics the sine wave? So maybe it's not the transmitter's fault all that much, because it seems as if my sine wave is not that great. I still think there's probably a lot of distortion to be had. But you can see that the transmitter is also, here's the inside of that carrier wave. That's definitely not a good sine wave. So yeah, I think there's definitely a lot we can do with the transmitter as far as improving it, but maybe that's not necessarily my problem as far as transmission is concerned. I might need to, like you were saying, just increase the well, the volume of the output, you know what I'm saying? So maybe that's what I'll do right now, rather than get too technical. Just hook an antenna back up to this thing and basically play with the volume of the output and see if I can't get a better range. Maybe it's expecting much more volume than what my computer could produce. But I do say that, look at this, you can see when I get to a higher volume, you can see that basically it becomes quite distorted. Well, let me put it on channel 1, I'm sorry. So I'm guessing that I don't know. I think the thing is trying to work too hard or something is my guess. I don't know, but I'm just learning here. So that volume, by the way, let's measure that. 10 volts. So it looks like maybe 5 volts peak to peak. I'm sorry, 5 volts up, 5 volts down, so 10. Maybe 1 square, it might be 5 volts now. Here we can cursor that. Am I in the millivolt scale? No. I think, oh, there you go. Source is channel 2, there you go. So yeah, 8.3 volts, peak to peak. So what is that, about 4 volts? So anyways, 4 volts going into it. And I'm just learning, so take you with you in just a little bit. Maybe I'll get that antenna hooked up and see what it does. All right, so I got the audio going directly into the transmitter, and I got an antenna on the back of the transmitter and a radio tuned into the signal. The signal right now looks like it's going in, that the input signal is about, it says 1.56 volts peak, so maybe peak to peak would be, is that twice that? Would be about 3 volts. I thought there was a peak to peak. Oh, I guess that's 1.56. I'm sorry, 1.6 volts peak. So it's about half a volt on the upper part, you know, and half on the bottom part. Anyways, all right. So you can see that increasing the voltage or the amount of audio definitely has an input on the sound. I haven't tried to get that out away from the radio, taken away from the transmitter. So let me go try that now. So I got the radio about oh, I don't know, about 8 feet away from the transmitter, maybe a bit more. I got the attenuator or the volume on the output max. It's probably about 20 volts peak to peak. Hope I'm not frying anything on the inside of that thing, but it seems to be okay right now. I won't be doing it for long. Just wanted to show you that I basically have no signal. No signal on the radio. So at peak volume, 20 volts input, I got nothing on the radio. So I guess my next step maybe might be to look at that. Sorry, I accidentally pressed stop. I guess my next step might be looking at that 6.3. I'm sorry, not 6.3. The 120 volt filaments. Put it in on the top side of the AC. Let me show you. See, they take theirs. Here's the filament voltages. They take it before the transmitter. So maybe I should look at that, as well as do, you know, of course, the wellness check of voltages and all that on the inside. So didn't want to do it, but maybe I think the next step might be to take this transmitter back out and do some more testing. So I got the transmitter out of the case now. I left the transformers in because boy, they were a pain in the butt to get out, or actually put in, I mean. No signal going into the transmitter right now. But I probably should put in my little dummy load that I had before. I have this little I saw this on a video I was watching. The guy put in a 600 ohm resistor just to basically have the nothing floating on the input side of the transmitter. So let me see if I can do that real quick. Hold on. Gotta find my green or my gold connector. Where did I do it though? There it is. Hold on. Well, I gotta put you down for just a second. Hold on. Ain't no doubt that one of these days I'm gonna be on video and actually touch the B+. And I don't think I'm gonna be as good as you by not saying what you said. I'll probably say a lot worse than that. Anyway, so I got it across the main input right now, right here, and it's 118 volts from 0 to positive, 260 volts peak to peak, and then so would that be about right? Then I think 124 is coming on the input. At least I measured that yesterday. So as far as it's transmitting a carrier wave right now. I can turn it on and show you. There's the carrier. Not very strong. It's 10 millivolts a square, so peak to peak must be like, I don't know, 20 millivolts plus 20 millivolts, 40 millivolts peak to peak. So maybe, yeah, it looks like around 44, if I'm looking at it correctly. Millivolts. So that's not a whole lot, is it? I haven't tried to rewire the filament heaters to put it on the front part of the transformer rather than on the protected or isolated side. We are still getting tube filament that seem to be lighting up at the right. Well, you know what? I got to tell you, this one is. Remember, I told you I couldn't even touch it before. This is actually touchable. Look, I'm touching it now. So I wonder if that has something to do with it, because before, remember I showed you that video where I just couldn't even touch it at all. It was like almost 200 degrees in some spots, and that was just with the transmitter. I'm sorry, with the filament voltage of the 117 volts or whatever that was being provided on the. Oh, I didn't even have a transmitter. I'm sorry, a transformer at that point. So it was all off mains voltage. So that's kind of interesting to see that. Maybe we'll switch it real quick and see what the difference in the transmission level is. All right, so I got the filament voltage coming directly before the first transformer. So coming basically out of the main supply, coming into pins 2 and 3, down on the heater valves. This is now pretty exceedingly hot, whereas before it wasn't. Interestingly enough, the carrier wave went from, I think, 26 millivolts to, I believe it's now 66 millivolts. And I've just got it basically zoomed in on the top of that rail. I don't know if you remember, or the top of the carrier. I don't remember if you remember before we were looking at the noise and it turned out to be a 60 hertz hum or a 60 hertz, ripple. This looks more pronounced doing what we're doing right now than it was before. I don't have a reference to show you, but in the video before it was much smaller. Let me just measure it, of course, real quick. I'll go to cursor. Let's go to this. Move him. Oh no, I want to go to the other cursor. I'm sorry. Hold on. Yeah, we'll just do it. Let me just run it once so I can play with it. Let's go peak to peak, shall we? And again, you can see that it's 60 hertz. So we're getting a bit more of a filter. I'm sorry. Oh gosh, I'm tired. Getting a bit more of a ripple of the 50 hertz signal. I wonder if that's because it's not isolated anymore. As my guess, it's like it's got actual mains coming into the filament itself, And maybe that, oh gosh, you know what, how you're supposed to like keep the mains wire away from all the other input and output wires and against the side of the chassis. Well, look at mine, is just going through the mess of all those wires. So ain't no surprise that that's got some sort of 50 hertz hum to it. Going back here, let's put that down to position. Let me see if I can get. Is it? No, I don't want to do that. Where am I doing here? Channel 1, AC coupled. Is it down to 0? What is going on? All right, well, listen, let me press pause while I get this thing fixed so I can show you the actual carrier. Dummy me, I still had it on the stop frozen screen. I'm like, I tell you, there's so many easy ways to make mistakes. Like, for example, I was taking the voltages over here, and I had my my ground, my negative clamped up to here, and my voltages were all way off. Like, you know, like the mains was like, you know, like 4 volts, and it was just like, what is going on? Is the transformer broken? And I figured, you know, it out eventually that it was connected over to here, which is not really connected via the negative on both of these. When I had it in there, it was connected through that screw right there, energizing this chassis or connecting this chassis as well. So basically, I just had it on the wrong chassis, and then everything went back to normal. But so here's the main carrier. You can see right now it's at 70. I think it was at 26 before, and it looks like at the top, it looks like it. So peak to peak must be like 140 is my guess. Yeah, look, 140 millivolts peak to peak. And you can go in, we can zoom in. Oh, I've turned it up, hold on. Hold on. You can see the sine wave is still kind of messed up. I got trigger in for channel 2, so let me change that to channel 1. Turn off channel 2 at the moment. I can't tell. Nah, I was gonna say maybe before there was that left and right jitter before. So yeah, we still definitely seeing a lot of what I'm guessing is like, you know, harmonics and other distortion. I bet you if my Tiny SA was working, which by the way I'm gonna just have to save up for another one when I can get some more money, but I bet you there would probably be the carrier right here, and then there'd probably be several that are being whatchamacallit, you know, broadcast on other harmonics, etc. So that's where we're at. I haven't actually tried to see if keeping it, if putting an antenna on it would allow my radio over there to pick it up better, to receive better. So why don't we just try that, put an antenna, instead of going straight to the oscilloscope, we'll put it on that antenna again and see if we can't get any more better performance or better signal transmission with the antenna, with the heater voltage going straight from the main supply. We got it back into the oscilloscope again. Again, the peak voltage is 141. The top voltage is going to be, it says 80 volts, you know, it's 20 millivolts of division, so there's 20, 40, 60, not quite 80, so what am I looking at, V top? Base, I think the distortion is causing the measurement to be off. Let me add a trigger in there, or I mean, sorry, the cursor. Go to the horizontal, move him up to the top. Sorry, I get it, focus on what I'm doing, I forget what you're doing. You're not seeing the same thing I'm looking at. I guess this is gonna be the middle, this is half, this is 0. And we got a change in voltage of 69 millivolts or 70, 69.6 or 70. So yeah, so 70, back to the calculator. So we got 70 peak to 70 peak. Boy, hold on. We got 70. No, it's millivolts, isn't it? So escape there, 0.07 times 0.7071 for the RMS, 0.7071. So that's equal to about 49 millivolts squared. Let me figure out where my mouse is. Squared and divided by 50 is my guess for the ohms, V squared over R. And I forget what the number was before, but wasn't this more? Let me press pause in here and go back to my video and see what it was before. But right now we're at, what, 0.048. Is that microvolts? I'm sorry, is that 48 microvolts? Anyways, it's got 000 and then a 0.48. So let's see what that was before. Yeah, so I just went back in the video, the first video that I sent or recorded, and it was 0.000, I think. Was it 312? I think it was 312 or 0312. Anyways, I think that this current setup with the filaments going into the actual AC, the transmission power that I've at least can calculate as I did before is now 1.57 times greater than before. So about 1.5 times better as far as the transmission. Still no receive on a radio that's about 3 or 4 feet away. So, well, 3 feet away, probably, yeah. So let me just get it really close, and I'll show you that it is indeed the distance. All right, so that antenna is up, basically just pointing up right there. And then we come over to here, turn the radio on. Tell you what, let's maximize our chances and seeing if I can't get it a little bit closer still. But I'm right here for right now. I don't know about you, but I'm foreseeing a fallen radio, and I don't want that at all. No, I don't see anything. Or rather, I don't hear anything. Well, now that we got a larger carrier, let's see how much power is coming out of that carrier. Assuming that we did it right the first time, let's see if it's any different. All right, so I made a kind of a dumb mistake. The silence that we're hearing is the carrier that is being picked up. See, it's touching the back of the radio through the transmitter. So here's my noise, and then here's the carrier. So I forgot when I did my test before, you know, to put in a tone. So I was listening for a tone at that time, but I forgot that I didn't have a tone in. So let me go back to my signal generator, put in an audio frequency tone into the input of this transmitter, and see how far we can get the transmission to be heard. All right, so I got the audio coming in out of the radio RF generator, going straight into the transmitter now. And look at this. Oh, I got it the same distance away. It was about, I guess that's about 3 feet now, 3.5 feet. Sorry. So there's the radio on top of the oscilloscope. And then there's my transmitter, but watch this. So you can see that we're definitely getting a better transmission, and this is just laying down, pointing this way. I wonder if you can touch it, and does that make a difference? Yeah, it does kinda, huh? I'm just moving the antenna. And that's kind of increased. Let's see how far back we can get it. In fact, I think I might need to turn the radio off, unplug it, and go to the plug up there, which I have into my light socket. There's a plug up in that little plug adapter. That's my closest plug that's away from this area. So let me go try that. Kind of the strangest thing, you can hear the tone coming out of the radio, I hope. More static than before, but still you can clearly hear it. And I say strangest thing because I had it plugged up into this lamp right here, the light bulb, and I couldn't get any signal at all. And then I plugged it back in the same power strip that the radio is plugged in, and it started to work. Let me show you. So hold on. I'm not going to touch the radio right now, but I'm just going to leave it there. I got to put you down for just a second. Hold on. You still there? There's nothing. All right, so there's nothing. So let me put you down again. Put you back over to the other plug. All right, I'm gonna retune it basically because I'm sure I messed it up. There you go. So I don't know. You think that there's not enough voltage in that plug because of the light bulb? No, that doesn't make sense, does it? We got to get going to church pretty soon, so I can't do too much more thinking on it right now. I might press pause and send you all these videos because I'm sure this is getting long, and see if I can't come back and make some more sense out of it, and maybe even improve the waveform and everything by adding in some line filters and all that. All right, love you. Thanks for all your time, for being here, for helping me, and I appreciate you.